Hello and welcome. My name is Fredrik Andresen. In this webinar, we will delve into the challenges of anchoring and footing designs, exploring failure modes and conservative approaches, while showcasing the advanced capabilities of IDEA StatiCa 24.1. We will also have a demo to show how it actually works. And in the end, I will go through what you need to know how to set up a correct model. First, let's look at the challenges. These are the failure modes of anchor details mentioned in the Eurocode, both for steel and concrete. The most critical failure modes are often the ones involving the concrete breakouts. And the question then arises, how can I deal with this? In some cases, the simple solution is to enlarge the concrete block, but for most cases that is not possible or economical. So the other solution is to introduce reinforcement. And the code says that when the design relies on supplementary reinforcement, concrete cone failure need not be verified. But it also says that supplementary reinforcement shall be designed to resist the total load. In other words, for us to be able to ignore the breakout failures, we need to calculate these forces and take them into account. However, the process is not as straightforward and easy as it sounds. The reason is that supplementary reinforcement is sized for the most loaded anchor and is then placed symmetrically around all other fasteners in addition to the existing one designed to resist the other actions on the concrete member. This can quickly become a detailing and fabrication nightmare, causing bar congestion. But luckily, the Eurocode allows the use of underutilized reinforcement to reduce the area of supplementary reinforcement. But on the other hand, there is really no instructions on how to determine the underutilized reinforcement. So, when facing all of these challenges, how can you deal with this and how can you calculate it? This is basically what the IDEA StatiCa software will help you with. And the solution is the 3D functionality in the detail application. It will basically let you check these failing anchors that can be solved by reinforcement. That means that with 3D detail at your disposal, you will have a quick and effective tool that is considering the effect of reinforcement on overall capacity. It will calculate problems not solved or covered in the code. And of course, the outputs are code compliant and safe. Next on the agenda is to look at this workflow of checking these details. And often we start with looking at the anchoring details in the connection application. And you might find that the anchors are too close to the edge and that you have a failure. And in the connection application, you can't really do anything more because of the plain concrete. So you will have to jump over to the 3D detail application to be able to check the anchoring with the reinforcement taken into account. And these are the steps. So you can start in the IDEA StatiCa connection application and analyze the anchoring. And you will find the failure due to them being too close to the edge. You can then export to detail application, and the anchors and the base plate and all of the load effects are exported. When you're in the detail application, you can define the reinforcement. And the last step is to calculate and receive the results that consider the reinforcement in the concrete, giving you a complete check of the anchoring. Together, the two applications cover all failure mechanisms for anchoring in reinforced concrete. And in other words, in the connection application, the pull-out and steel failure on the lever arm are covered. And in the detail application, the steel failure, the concrete cone failure, and the splitting failure are covered. And to make this even more clear, we have some clarifications about the differences between the connection and the detail application. So the first one is, how is the design of anchors and concrete carried out? Well, in the connection application, the connection block is considered as plain, unreinforced concrete. The anchors and concrete are checked with the formulas from the code. And in the detail application, the concrete can be reinforced. And in fact, it must be reinforced. And the block is reinforced, and the block and reinforcement is modeled as finite elements, and the 3D CSFM is utilized. Second one, how is the concrete block modeled? Well, in connection application, the block is modeled as a 2D 𝘊𝘯𝘰𝘵𝘪𝘯𝘨 subsoil model, which only allows for compression. And the contact stresses between base plate and concrete are calculated from the formulas and averaged over the effective area. In the detail application, the 3D concrete block is modeled by solid elements with where triaxial stresses are considered. As a result, we get the equivalent principal stresses that are compared to the concrete strength in compression. As previously mentioned, you can export the detail from the connection application to the detail application. So the stresses in the welds are exported as a group of forces in lines that are mirroring the shape of the column. And the forces in anchors are exported as pairs of forces. First, there is a tension force acting on the anchor, and secondly, there is a compression force resulting in the opposite direction. And together, they are maintaining the equilibrium. The last question to clarify: is the concrete considered cracked or uncracked? In the connection application, you as a user can decide if you want to consider the concrete cracked or not. You can do that in the project settings, but in the detail application, the concrete in tension is neglected, basically. So it depends on the load if the concrete is cracked or not. The application will calculate it for you. I will also dedicate some slides to the method on which the program is based upon. It's called the 3D CSFM, and it's short for Compatible Stress Field Method. And this method, it is a nonlinear finite element calculation method capable of considering reinforcement in concrete. And further on, this 3D CSFM method defines the concrete behavior based on the modified Moore column plasticity theory for monotonic loading. The method considers principal concrete stresses in compression and reinforcement stresses at the cracks while neglecting the concrete tensile strength, except for its stiffening effect on the reinforcement. The reinforcement bar are linked to concrete volume finite elements through bond elements, allowing for slip between the concrete and reinforcement. And as previously mentioned, it should be noted that 3D CSFM is not suitable for simulating plain concrete due to the absence of tension, which may result in misleading deformations and model divergency. Generally, the Moore column theory includes two fundamental properties governing the evolution of plasticity surface in compression and partially in tension, and that is the internal friction angle phi and cohesion parameter c. The method also assumes a zero angle of internal friction, leading to a conservative design due to the plasticity surface resembling the 𝘔𝘂𝑎 model, which is independent of the first stress invariant. And this method, it is implemented in the detail application, and it's verified and compared to lab experiments and abacus. And in this slide, we can see the different results for anchors of 3 different lengths, same diameter. And it shows that the 3D CSFM are the most conservative compared to the experiments and abacus results. And the yellow column, it represents the design values, showing that it's a significant safety buffer in our designs. So to the demo, here we have a anchoring detail in the connection application. It's a simple column welded to a base plate and fastened to the concrete with 4 anchor bolts. It's located near the edge of the concrete block, and that can be an issue. This column, it's loaded with a compression force and a moment, resulting in these two anchors being subjected to tension. And if we see at the code check, we can see that the anchor tensile resistance, it's not really a problem. But if we go down, we can see that the concrete breakout resistance of anchor in tension, they are failing. And in this case, we can't really make the concrete block any bigger. So we have to introduce reinforcement to check this detail completely. So we can export the results into the detail application by clicking this button, RC check, and then the concrete block will be exported. So now we open the detail application, and here we can see the concrete block with the base plate and the 4 anchors also. And we can see the parameters that were exported. We are now in the design window. If we go back to the project tab, then we can see that we are dealing with the Eurocode still, and we can go back to the design tab. We can also look at the materials. So here we have the exported materials. First of all, the concrete, then the reinforcement and the anchors, and also the steel for the base plate. We can see that we have a error message, and basically it's because there are no reinforcement yet, and yeah, so now it's just plain concrete. We can also review the details on the right side and all the parameters. So first of all, we can edit the reinforcement, the concrete cover to 45 millimeters, and we can look at the concrete block, and we can see the materials, and then the support. You can have, by default there is a whole surface support in the bottom of the concrete block. You can also have a polyline if you want to have patch supports. And then we can define the spring stiffness of the support. For example, the soil properties. And you can also choose to have compression only support. But there might be cases where you want to have a support active in tension as well. In those cases, keep in mind that the concrete is never in tension, so we will have to define reinforcement that will take the tension. So in these cases, we will define some reinforcement. We'll place them on the correct edges with the correct number of layers and the distances. And now we can then define them as continuous so that they are able to take tension. We can see it here. And then we have the base plate. So here we can see the thickness and so on, and the shear force transfer mechanism. We have available friction, shear lug, and anchors. And also the friction coefficient. It's set at 0.25 by default, but we can edit it if we want to. And then we have the transfer devices, so the anchor bolts. And we can choose from adhesive anchors or cast-in-place anchors. For the adhesive anchors, the default bond strength value will be 5 megapascals, but we can also choose a cast-in-place anchor. And the bond strength for the cast-in-place anchors, they are calculated according to code. And then we have these checkboxes for interconnecting with the base plate. And basically it allows us to define multiple base plates and multiple anchors that are not connected to base plates. And therefore we can define how the anchors are interconnected with the base plates. For example, the code may require that all the shear should be transferred to the anchors on the edge. So you have that option. Now we can look at the load effects and add another load effect with the self weight. And then the load combinations. And we can edit the load factors. And then we can go on to looking at the reinforcements. So first of all, we can edit the first group of bars and add some more reinforcement. And here we can change from a perfect bond to, for example, a hook or a bend at the end of these reinforcement. And now we can copy the operation and add another layer. So this will be in the other direction. And simply just changing the surface. And we can copy the operation one more time to add the horizontal reinforcement. So it will have some different parameters and we will define the correct surface. And we will copy it again. And this time we will define it not on surface edge or more edges, but on surface edge. And then, so these will act as parts of the stirrups going through the middle of the concrete block. So we will distribute them evenly over the concrete block, like this. And now, lastly, we will define how these bars will be bonded. So we will define a perfect bond so that they will be a part of the stirrups. And now we can go through the settings, and a little tip here. To do preliminary checks, we can define or edit the multiplier of default mesh size to 2. That will save you some time when running the analysis. So we set it to 2 in this case. And you can of course go back and reset it later. So now we can run the analysis, and here is the results. So first of all, we have the summary of the code check. Here we have, in this case, green check marks, and we can see the utilizations of the concrete, the reinforcement, and the anchorage. And then we can move on to look at the strength, to see the stresses and strains in the concrete or the reinforcement. We can also create a section view to see how the concrete behaves in the middle as well. And here we can see the stresses for the reinforcement. And we can see here quite well that the stresses from the anchors, they are transported, or they will transfer the stresses to the neighboring reinforcement as well. We should also take a look at the auxiliary, so the deformations and the displacements, to look for instabilities of the concrete block, to see if it tips over or moves. And here everything looks good. We can also check out the tensor concrete values. So we can see the stresses and the strains, and we can study it in detail. So here we can see quite nice that the stresses in this anchor in the corner behaves as expected. And then the last step is to create the report. So here, as always, as in the steel application as well, you can input what you want the report to contain, and generate a report, and it will give you all you need to know. And you can see here the code checks, visual plots of the stresses and strains of concrete and reinforcement. So back to the slides. And we can look at what types of settings that you can do in the connection applications. So you can modify the material and dimensions of the anchors. You can also specify the type of anchor and method of shear force transfer, which in this case is friction or anchor or 𝘊𝘰𝗪𝘯𝘪𝘯𝘊𝘩. And regarding the types of anchors, for the cast in place and pre-installed ones, you can choose from straight or hook or anchor ended with a washer plate. You can see them here. There's also the possibility to use post-installed anchors, but only the adhesive are available in connection and detail. The mechanical, it's not available now. For the adhesive anchor, the technical specifications of the anchor manufacturer must be used. And the default value of the bond strength, it's set to 5 megapascals. You can of course edit it if you want to. So when the anchor are exported into detail application, they will be converted as following. The straight anchor is exported into detail as adhesive, and the hooked anchor are exported into detail as pre-installed reinforcing steel rod ended with a standard bend. In detail, there is even more types to choose from, and you can see them here, also with the following beta factors for the straight, the hook, bend loop, welded transverse bar, perfect bond, or the continuous bar. And the transfer of loads. The load can be defined either to the anchor directly, and in this case the load is transferred to the concrete directly. The tension, the compression, and the shear as well. The other alternative is to have the load on the base plate, and you can choose which anchors are used to transfer the load. And as you can see, you can choose the interconnection of individual anchors with the base plate, as I showed you and mentioned earlier. And this is important, especially for shear transition. And shear can be transferred via 3 transfer devices. It's these 3 devices. First one is friction between the base plate and the concrete surface. Anchors do not act in shear in this case. The second one is anchors, and the last one is via a shear lug that is welded to the bottom of the base plate. And it should be noted that interaction of these types are not possible. Regarding the base plates with a standoff, either via a gap or a mortar joint, it's not available in the detail application. But most likely it will be in the next version, version 25, coming out in the spring of next year. So we will see. I would also like to show you where you can find more about the 3D detail functionality. If you go into the website of IDEA StatiCa and you go to the support and learning, you can go to the support center, and here you will find the theoretical background. And here we have the structural design of concrete 3D discontinuities. So here is the theory and the method behind and everything you need to know. I would also like to show you all of the sample projects that you can browse through. I will filter out the concrete and the 3D details. So here are some sample projects that you can download to your computer, and you can check them out and find some inspiration if you want to do that. So thanks for watching. Hope you learned something, and see you next time.